Hi there everyone. Welcome to the video lecture series on complex variable and analytic functions. In this video lecture I am going to take this question to show that the function f of z equals to sin z is analytic and also find its derivative. So let us see how to do this. So the first thing we will be considering over here is this function f of z, which is sin z. Okay, now as the steps that we have seen in all the videos so far, that the first step that we are going to do is we'll put f of z as u plus iv and z as x plus iy. Therefore what we do here is u plus iv is equals to sine of x plus iy. Now if you know the expansions of sine x plus iy, I had already given in the basic video lecture regarding this, but if you do not know, I'll show you the expansion here, how it is done. You can directly use a formula. I'm just going to show you how these expansions are obtained. So you have sine x times cos of iy plus cos of x times sine of iy. Now we use the relationship between the hyperbolic functions and the trigonometric functions. So sine x times cos of iy is nothing but cos h of y, the hyperbolic cosine. Okay, and here it is going to be, see here we already see that we have here is sine iy, right? Sine iy is I times sine h of y. Okay, so that is the identity we have, the relationship there. So what we now do is this change comes here is this one, that plus of I times we write cos x and sine h of y. This is the expansion over here. So this is what we get. So therefore u, u which is ux comma y, now can be written as sine x cos h of y. Okay, and v, which is v of x comma y, this will be written as cos x times sine h of y. Okay, that is, these are the real part and the imaginary part. Now we go for finding the derivative, the partial derivatives, because we want to check whether the Cauchy-Riemann equations are satisfied or not. So we go for to check CR equations hold or not. Okay, so now we'll do the partial derivative here. So when we do the partial derivative of u with respect to x, we have da by u over da by x. So what we get is da by da by x operates on sine x cos h of y. That gives me cos x cos h of y. So the next derivative over here we calculate is uy, which is da by u over da by y. Now this derivative is going to be da by da by y operates on sine x cos h of y. So here we have sin x is constant because we are taking derivative with respect to y, and cos hy derivative is sin h of y. Now we calculate the derivative v suffix x. So daba v by dabba x. Okay, so dabba by dabba x operates on v, that is cos x times we have here sine h of y, right? So the derivative will be, derivative of cos x is minus of sine x, and here sine h of y. Now we take the derivative with respect to y for v, so it is dabba v by dabba y. Dabba by dabba y operates on cos x sine h of y. This will now give us cos x is constant, and derivative of sine h of y is cos h of y. Okay, so these are the four derivatives. Now we label them quickly. So let's label them. So they are, this is 1, 2, 3, and 4. Now from 1 and 2 we see here, no, not from 1 and 2, 1 and 4. Okay, from 1 and 4 we get that is ux is equals to vy. Okay, and from 2 and 3 what we get is u suffix y is negative of v suffix x. That is what we see. So this means to us that CR equations are satisfied. Okay, so they are satisfied. Now we go for the explanation that the partial derivatives are continuous. So how do we go and handle that? So this is how it goes. So we argue in this way. We know that sin x cos x sin h of x cos h of x are continuous functions. Therefore, therefore u suffix x, u suffix y, v suffix x, v suffix y are continuous. Okay, so are continuous, and hence f of z equal to sine of z is analytic function. Okay, so this is what we get. Now let us calculate the derivative. So we write here to find the derivative. On finding the derivative, we are going to use f dash of z. The formula is ux plus I v suffix x. So let us see how to handle this further. So ux we found that is sine cos x into cos h of y. So this is cos x into cos h of y plus I times, now the value for Vx that we have found is minus of sine x sine h of y, right? From the equation 3 we can see that. So it's going to be minus of sine x sine h of y. Now let me elaborately give you the solution for this. See, cos, now we again go the reverse way round. Cos h of xy, cos h of y over here, this value can be changed, this expression rather can be changed. Cos h of y can be written now as cos of iy. Okay, that is what it can be done. And further, when I see here, uh, what I can do is, this manipulation is possible. See, I can write here the minus sign, and the I which is there, if I take this I inside the angle over here, so what I get is, I will get here, first term will be sine x, and when I multiply or take this I, the because of that identity what we have here, it will become sine, the formula, the relationship formula that we have between trigonometry and the hyperbolic functions, the thing it will now give me is sine iy. This is what I will have. So now I get cos x cos iy minus sine, I'll just write the whole formula again so that it is clear, and this is nothing but cos of x plus iy, and this expansion is nothing but cos of z. So that's the derivative of function f of z. You can also solve the following questions for yourself on your own. I'll just give you some over here so you can do here, so you can find, uh, you can show that these functions are analytic and find their derivative. So f of z is cos z. So again, it's almost similar the way we have done here. Okay, second function I'll give you is f of z equals to e to the power z times z. Okay, so these are two functions you can try on your own, and let me know if you have any difficulty in these two questions in the comment section. I'll try to help you out if you face any difficulty, or we can have a small video for that too. So this was the content of my video lecture. I hope you liked the content and you have followed the topic. Please do hit like button and share it with your friends, those who find this topic useful. Please subscribe to my channel. I'll soon see you with the other videos on the following topic. Till then, keep solving good amount of mathematics. Stay tuned. Thank you.